All right, day 2 of me being out. We're on lesson 7.1.6, question 71. It says situation to question mark. It says use each of the situations below to complete missing pieces of the web or to practice moving from a situation directly to a specific representation. The web thing that it's talking about is not something I've shown you. Sorry, it was in the book before. Basically, it's saying like, how do you get from a situation to a graph, or a graph to a table, or a table to an equation? Like all the different ways you can do it. And we've been doing that. It's just I didn't show you the quote-unquote web to show what that looks like. So it says for each part, decide which representation you will generate from the situation description based on where your team needs to work. We're going to, work together today. So A says a 100-gram sample of radioactive isotope decays at a rate of 6% each week. Write an equation to represent this situation and then determine how big the samples will be 1 year from now. So we want to write it in y equals a times b to the x form. So the starting amount is 100, so that's A. And then B is going to deal with the decaying at 6% each week. So we're going to do 100 minus 6. And that's going to be 94, and that is a percent. So then we're going to take that and make it a decimal. So 0.94 is going to be our multiplier. So remember, when you're decaying, you subtract from 100, and then when you're growing, you would add to 100. So then, So it says how big will it be after a year? Well, since we were currently talking about weeks, we need to change 1 year into weeks. So there are 52 weeks in a year. So now we can write our equation, plug in information, and solve. So we're going to write y equals 100 times, my marker is not working great, times 0.95, and then x is going to become 52. So then you're going to type all that in your calculator. 100 times 0.95 to the 52nd power. I'm sorry, not 95. Oh my, I've been saying 95 for a while. You're probably like freaking out over there. It's 94. Can you tell I am sick? So 100 times 0.94. There we go. So we get 4.01, and then that was in grams. So it went down to 4.01 grams. Okay, so the next one says the math club is fast becoming one of the most popular clubs, obviously, on campus because of the fabulous activities it sponsors annually for Pi Day on March 14th. Each year, the club's enrollment increases by 30%. If the club has 45 members this year, write an equation to determine how many members it should expect to have in 5 years from now. So I started underlining all the important info probably. So we're going to write it in y equals a times b to the x power form. And then we're going to plug some stuff in to solve. So the starting amount of members would be our A, 45, times, instead it increased by 30%, so we're going to take 100% and add 30 to it to get 130% increase. So then I'm going to write it as a decimal, which would be moving the decimal place over twice, 1.30. So decay was subtracting, and then increasing was adding to 100. So then 1.30, and then to the x power. In this case, it was talking about years and then years again, so we don't have to convert any of our numbers like we did before. So we're just going to plug in 5 years. So y equals 45 times 1.30 to the 5th power. And then we're going to solve, which is a decimal 167.08. And you can't have 0.08 people, so I'm just going to say about 167 members. All right, so now the next one gets a little more complicated. It's asking for a table. If you see that bold on there. So let's go to C. It says Barbara made a bad investment. That's awkward. Rather than earning interest, her money is decreasing in value by 11% each week. After 1 week, she's down to just $142.40. How much money did she start with? Find the multiplier, create a table, and write an equation. So let's fill in to what we know in the table so far. It said after 1 week, she's down to $142.40. So at X is 1, I'm going to write $142.40. So I use that. And then it says we're going down by 11%. So we have to find the multiplier from that. So we're going to do 100 minus 11 is going to give us 89%. And then to find what that is when we're actually putting it into the table, we're going to say that is the decimal 0.89. Ooh, that is not pretty, sorry. 0.89. So to go forward, I'm multiplying by 0.89, which since it's lower than 1, it's going to pull me down each time. So I'm going to multiply by 0.89 to go forward. So to fill in the rest of the table, I'm going to do 142.40 times 0.89 to go forward. And note that this is money, so we want to round accordingly. So I've got 126.74. And then I'm going to have to type that number in to help me get to my next one. So again, I'm going to multiply 126.74 times 0.89. And my numbers should be going down. If they're not, we have a problem and our multiplier is incorrect. 112.798 makes that 8 after the 9 makes the 9 become a 10, which makes it 80. So 112.80. I'm going to write that number down. 112.7986. This number told this one to go up, which in turn becomes a 10, which makes this go to 80. So that's why that looks like that. And then 112.80 times 0.89 will get me 100 and then 39. And then that $100.39 is just dwindling. It's going away. Times 0.89 is 89.35 rounded. And then times 0.89 again is 79.52. Now to go backwards, we're going to take the 142.40 and divide by 0.89 instead of multiplying by it. So we get 160. So that's actually how much money Barbara started with. And we've got our multiplier, we got our table, now we just have to write our equation. So y equals a times b to the x power. A is the starting amount and b is the multiplier. And we didn't need to plug anything in because we're not solving for any of the pieces because we already have our table. So y equals 160 times 0.89 to the x power, and we are done with that part. All right, so take some time to wrap that up and we'll go to the next page. Okay, so now what if we go from a graph to an equation? So 769, it says, suppose the annual fees for attending a public university were $7,000 in 2010, and the annual cost increase is shown in the graph at the right. Obviously, the cost of universities, colleges are going up, so every year it's going to go up, which makes sense. And then it says, note that X represents the number of years after 2010, and that says that here because that's the X axis, and then Y is the amount of money. So it says, write an equation to describe the situation. So this is kind of like yesterday, But yesterday we just didn't have like this stuff on it. It just literally had numbers. So doesn't really matter about the words anymore because all we're doing is write an equation. So my 2 points that I have are here and here. And we were taking yesterday those points and putting them in a table. In this case, since we already have, we don't have to do that, but if it makes you feel better, I would do it. I personally like it. We don't have to do it. It's up to you. But I like it. So here are my numbers. 0 is at 7,000 and 1 is at 7,700. So I need my starting amount for A, which is 7,000 at 0, and then times, I don't know the multiplier, so I need to find it by dividing because the multiplier is going forward, so divide, go backwards. And then we also need to make sure that we are dividing the later number by the first number there. So 7,700 divided by 7,000. Which, oh, I did that wrong, which is 1.1. So my multiplier is 1.1 and then to the x power. So I've written an equation and then it's asking me to answer the questions using my equation. So it says, what was the cost in 2010? So looking back, I'm just reading from what it was in the beginning. It says 7,000 in 2010. And we know that 2010 was like our starting point. So year 0, technically we could go in and put y equals 7,000 times 1.1 to the 0 power. That's a 0, sorry, to the 0 power, but we don't need to do that because there's already a sentence there that tells us the answer. Now on part C, it says, use this model to predict the cost of attending a public university in 2015. So 2015 would be 5 years after 2010. So if you needed to write that down, you could, like 2010, 2011, and so on. But I know that's 5 years. So I'm going to plug in 5 into my x into my equation. If you wanted to write a table too, you could. But in this case, I think it would make most sense and it'd be easier just to pop that 5 into an equation. So y equals 7,000 times 1.1 to the 5 power. And remember, I don't have to convert anything here because we've been talking about years. So I'm going to continue to talk that way. So 7,000 times 1.1 to the 5th power, sorry, is 11,273.57. And then that, sorry, looking at the wrong answers here. And then that is your answer for the money that it would cost after that long. Ooh, that's a 7. So then it says, what was the cost in 2000? So that was like before 2010. So how many years before 2010 is that? That's going to be minus 10 years. So when we're plugging it into our equation, we're putting in that negative to represent we're going below our starting amount. So when we put that in, it doesn't give us a negative result. It just takes you backwards because it's like going down on the graph. So if you see me going down. So when we put all that in, that becomes $2,698.80. So when you're ready, we'll move on. Why am I saying that? I can't even see you. I'm sorry. I'm just used to saying that every time. 770. So 770 said equation to a graph. So it says for each equation below, make a reasonable sketch. So when I say a reasonable sketch, that does not mean it has to be completely 100% accurate, draw every single line. It just needs to have some specific things representing what's happening from the equation, and I'll show you what that looks like. So just gonna throw some graphs on there. And it says, again, this is something you would have done in your group, but we're going to do this together. So it says discuss your strategy with your team. We're going to talk it together. And then should your graph be increasing or decreasing? Should it change very quickly or more slowly? Oh, sorry if I made you yawn just now. So one determining feature that all of these should have is the starting value on the x-axis. So these numbers should somehow be represented somewhere on there. So I'll say 5's about here, 10's about here, and 1/10's about here. So, excuse me, not perfect, but yeah, they're close enough. So then I'm going to look at my multiplier, and that's going to tell me how things are changing. So we've talked about this before a couple of times, but look at a multiplier that's a whole number. That's going to tell me that I'm increasing, and then multipliers that are between 0 and 1 are going to tell me that I am decreasing. So this one is increasing. This is decreasing. And this is increasing because of being 3 and 5 are above 1, and then 1/2 is below 1. So I'm going to increase. Oh, that's not what I wanted. Sorry, I'm increasing and going through that 5. So from left to right, remember we're reading from left to right. I'm going to do C also first, increasing. And then D or B is decreasing. So it's going down from left to right. All right, let's go to the next one. Okay, so 768, it says situation to graph. A virus has invaded, I don't know how to say that name. Like, I'm just not gonna say it wrong. Their favorite mountain fishing lake. Currently, there are an estimated 1,800 trout in the lake, and the Fish and Game Department has determined that the rate of fish deaths will be 1/3 of the population per week if left untreated. So then part A says write an exponential equation for the situation. So the starting amount of trout is 1,800, so that's going to be our A. And then we're multiplying by how it grows. So we kind of need to be careful because we're trying to show like how many are living. So 1/3, it's not growing, sorry, how it's decreasing, but 1/3 goes away. But to show what is left, because we're doing 100 minus, remember that, if I'm taking away. So 100 minus 1/3 is 33.3 repeating. So I'm just going to say instead 1 minus 1/3 is 2/3 is what's left. So this is just like we were doing before with 100% minus. Here I'm just doing 1 minus because it would be kind of weird to try to write it as a repeating decimal. So 2/3 and then to the x power. So just as a reminder again, because there were trout dying, instead of writing 1/3 there, we're writing 1 minus 1/3 to represent what's going to be left. So then part B, it says how many fish are left after 12 weeks. So currently we are talking about in terms of weeks, so we don't have to convert anything. And then we're going to plug in write our equation, and then plug in to the 12th power because that's 12 weeks. So when you pop all that in your calculator, 1,800 times 2/3 to the 12th power, you'll get 13.87, but since we're talking about fish, we're going to round that to a whole number, so about 14. If you want to write about 13, that's fine too, and we'll write specifically trout, not just fish. So, all right, we are going to do some of the review here. Let's do number 1, and then we will not do number 2. So number 1, it says simplify the expressions below with no negative exponents or decimals. So this first one, you're going to square every single piece because of those parentheses. So 4 squared, x cubed squared, and y squared squared. So 4 squared is 16 because that's 4 times 4. And then x cubed squared would be 3 times 2, so x to the 6th. And then y squared squared is 2 times 2 is 4. So when you're doing a power to a power, you multiply. So then on the next one, it looks like a lot, but you're just going to separate piece by piece. So I'm going to start with the 5 and 20. So 5 divided by 20 is 1/4, and I'm just going to write a long line so then I can continue. Then I'm going to pick a different color just so you can see here. -4 and 3. So that -4 needs to actually go down to the bottom. And then that 3 stays there because it's positive already. So 4 plus 3 is 7, so it's a to the 7. And then the next one, that is 9 and then -1. So that -1 is going to go to the top, and that becomes a 1. So 9 plus 1 is 10. So b to the 10. Since I have a number there, that 1 can go away. You can also leave it there and it's fine, but I'm just going to delete it. If there was nothing there, then it would need to go. Or sorry, it would need to stay. So then the last one, let's pick a different color, is the C's. So this C needs to go to the top. 0 plus 2 is 2, so C to the 2nd power. And then I'm just going to clean up my lines a little bit, and it's done. The next one is combining kind of like we did in B, but just with multiplication. So 3 times 5, which is 15. 2 and -1. So 2 times, this is where it's different. When you're not going up to a power like this A here, you're not multiplying. You multiplied an A, but here we're just adding. So 2 plus -1 is just 1. So x to the 1st. And then the last one is y to the 4th, y to the 5th. So 4 plus 5 is 9. So y to the 9th. And then this could still be simplified to 15x y to the 9th because x to the 1st can be just x. All right, hopefully you'll have some time for your homework.